Hello, AP Stat students. This is Miss Taylor. I do miss you guys. I wish we were in class. I wish I can see you, but nevertheless, we're moving on. So this is the next thing we teach in probability, which is probability rules. So, and it's not that bad. Most of it, a couple of the things is intuitive. You've already learned. So let's get started. All right, so probability in general is denoted by P of an event. So we know when we're looking for the probability sum is what we want our favorable outcomes over our total. So I always say it's the choices that you have of what you want over all your choices, your total. Okay. Experimental probability is actually just to run an experiment and just see what you get. So when you flip a coin, you just actually count what you see. That's experimental probability. And the more times that you do experimental probability, which is the law of large numbers, the closer you get to what is zero side. So even though 17 out of 30 is not what you expect half, but the more you do it, you should get closer to 1/2 because that's the probability of flipping a coin and getting heads. All right, those are the rules that we're going to look at today. We're going to look at each one of those rules and one of our examples. Also, I did post the notes if you want to follow along, if you can print. So let's get started. So this one's going to be easy. You already know how to do this just from the table that you did, probability with tables. Musical styles other than rock and pop are becoming more popular. A survey of college students finds that the probability they like country music is 40%, the probability they like jazz is 30%, and that they like both is 10%. What is the probability that they like country or jazz? So we're going to use a rule that we've already seen. And so on the table, I would say, well, take the number that you have for A plus your second event and then subtract where they intersect. It's the same thing we're going to do here. The probability of country or jazz equals the probability of country plus the probability of jazz minus both. The probability that you like country and jazz. And so all those numbers are plain to see for us. I just drop it in the formula and I get my answer. The probability of country or jazz is just 60. All right, so let's keep going. You know how to do this one too. Suppose I will pick 2 cards from a standard deck without replacement. What's the probability I select 2 spades? Well, we've seen this before and we understand that the second fraction is based off the first fraction happening. So 13 out of 52 times, I took the spade away and I took a card out the deck. So we also understand that too. So you know how to do that. All right, so this actually is intuitive too. So it says a certain brand of light bulbs are defective 5% of the time. You randomly pick a package of 2 such bulbs off the shelf of a store. What is the probability that both bulbs are defective? So we know that being defective is 5%. Can we assume that they are independent? I would say yes, because one bulb defectiveness cannot affect the other bulb to be good or bad, okay? So they're independent, so it makes math easy. So all we have to do is just do multiplication like we did in our other problems. So just like we did rolling a die and flipping a coin, we just multiply them separately without changing denominators. So that's what we're going to do here. The probability of being defective and effective is 0.05 times 0.05 because it's 5% chance of being defective for each light bulb. And you just get your answer right there. Easy peasy. All right, so let's keep going. So B, it says, well, what are the probability that both are good bulbs? Well, if 5% of the time it's defective, then the other math would be 95% of the time you have to be a good bulb. And so you have those yeses and nos. So 5% bad bulb, 95% good bulb. So when you do your math here, the probability of good and good, or 2 good bulbs, is 0.95 times 0.95 because I'm representing my 2 bulbs in the package. Okay, so now we're at example 4. A certain brand of light bulbs are defective 5% of the time again. What is the probability that exactly 1 bulb is defective? And if you're thinking, you're like, oh, this is not that bad because I need 1 good bulb and 1 bad bulb. And you're right. So you're in your head, you're like, oh, it's got to be 0.95 times 0.05. You're almost almost right. So let's talk about what could happen in this box. All right, so in the box that we have, there are certain scenarios that could happen. So these are all the things that could happen. You could have two defective bulbs, or remember, you have two bulbs. One is on the left and one is on the right. So the left one could be defective and the right one could be good. Or the left one could be good and the right one could be defective. Or they both could be good. Those are all your possibilities. So when you're saying what is the probability that you have exactly one good bulb, there actually are two scenarios that can happen. The scenario here can happen and the scenario here can happen. So now let's look at the math on how we do each combination. So obviously defective and defective, we know how to do that one because it's 5% times 5%. Good, defective and good, that makes sense. 5%, 95%. Two bulbs, 95%, 5%, and good, we learn how to do that. So how do we represent that? That's just the math for each one. And I want you guys to notice something. If you figure this out, if I added all of these up, since this is all the possible scenarios that can happen with these two light bulbs in a box, guess what they have to add up to? 100% or 1. So remember, probabilities for every possibility in your situation that could happen needs to always add up to 1. There's no way it can't. All right, so let's keep going. So what is the probability that exactly one bulb is defective? Well, you need the probability of defective and good, or what could happen is good and defective. And when we have two scenarios where one could happen or the other, that or word comes in, and we have the addition that happens in probability. So we have 0.05 times 0.95 plus 0.95 times 0.05. We add them together. So adding these two right there gives us our answer. Okay, so let's try another one. Same thing with the light bulbs. We're just going to stick to light bulbs. A certain brand of light bulbs are defective 5% of the time. Again, what is the probability that at least one bulb is defective? She's like, what's the probability of at least one bulb being defective? Well, let's go back to our choice. Well, where are all the things where at least one bulb is defective? Well, one bulb is defective here, because it says at least one. It doesn't matter if I have both of them. It just says, it didn't say exactly one. It says at least one. So at least one means, oh, I just need one of them to be defective. It doesn't matter if both of them are. So we need this situation and this situation also. So we need those three. So what is the probability that at least one of the bulb is defective? So we need all of those, and that's our math. And you're like, okay, this is getting out of hand, right? There's got to be an easier way to get at least one instead of me adding all the combinations. Because what if I said it was 4 bulbs in the package? Then, you know, there are there's a lot of choices for 4 bulbs in a package, and I can't just do this every time. So here's the rule that we like to use, the at least one rule. So if you go back and look, we'll go back and look at the situation. If you just subtract the one that doesn't fit your scenario, then the other math will give you the addition of all the other situations. So let's look at our chart again. Okay, well, here it says at least one defective. So we need this part of the graph. Those represent at least one defective. The one that we don't need, that doesn't represent at least one defective, is this baby over here. He's the one that doesn't no defective. There's no defective in this one. And remember, I told you that all the math at the bottom equals 1. So if I could just take him out and subtract him from 1, then it would be easier to do at least. So let's look at the math. We should get the exact same answer. What is the probability that at least one bulb is defective? So the probability at least one bulb is defective, that's 1 minus the probability of non-defective. Or you can think about it as 1 is the probability, 1 minus the probability of good and good, because that's what I'm taking away to use all the defective. Well, the probability of being good is 0.95 times 0.95. I subtract it, and I get the exact same answer as for adding the rest of them. It is the rule that is used the most because it is easy to do this rule. If we were on a multiple choice test, they use this rule all the time. This is one they always use at least one because it's easy to test and it's easy to track. You only have to worry about one situation. So it's a good rule. Okay, so let's try it with our Coke bottle because my time is winding down. You know, I don't like to go this long. For a sales promotion, the manufacturer places winning symbols under caps of 10% of all Dr. Pepper bottles. I hate Dr. Pepper. You buy a 6-pack. What is the probability that you win something? All right, so you need at least one winning cap. The only way that you don't win something is that none of the caps are winning. So remember that. That's the situation I need to take away. I need to take away that my 6-pack has no winning cap, no winning cap, no winning cap, no winning cap. Well, what's the probability of me not winning? 90%. All right, so here we go. Probability of at least one winning symbol. All right, so that means I need to go 1 minus no winning symbols. Remember, I have a 6-pack. So that means I'm going to have to multiply something 6 times. When we did 2 light bulbs, we had to do it twice. So with a 6-pack, you're going to have to do it 6 times. So, well, what's the probability that a cap is not a winner? Well, that's 90% because we want low chances of people winning. So it's 90% of not winning and 10% of winning. So we're going to do 1 minus 90%, 90%, 90% times 90% times 90%. Well, I don't want to write that out. It's got to be a faster way to do that in math. It is 1 minus 0.90 to the 6th power. And we get that answer. So that's another example of at least one. All right, so you'll get the practice on it in our practices. All right, conditional probability again before we start. A probability that takes into account a given condition. Remember the probability of B given that A occurred first, or I know A happened, or I have information about A. So this is just using the formula. So this is simple. In a recent study, it is found that the probability that a random selected student is a girl is 50%. So I know the probability of being a female or a girl is 51. I have that. And is a girl and plays sports is 10%. So to be a girl and play sports is 10%. So the probability of girl and sports is this. All right, so now it says if the student is female, please remember your if you're given. What is the probability that she plays sports? So we need the probability of sports given that I picked a student as a female. So I have to put the probability of sports in female at the top over the probability of just being a female. And I do that math and that's it. That is actually my last example. So, students, now we've ended our PowerPoint. So hopefully you understand that you'll have some work to do and some practice problems. I'll host a Zoom later on today or tomorrow since I know I get you stuff late. So just let me know if you need some help. I'll send it out. You guys can give me suggestions. I miss you guys. I'll talk to you later.